Now we are going to solve one problem. Solve the linear recurrence relation an minus 7 into an minus 1 plus 10 into an minus 2 equal to 0 for n greater than or equal to 1 with a naught equal to 3 and a1 equal to 3. So first initially we should assume let g of x equal sigma n equal to 0 to infinity an into x power n. So as a first step we should multiply the given equation with x power n on both sides. So it will become an into x power n minus 7 into an minus 1 into x power n plus 10 into an minus 2 into x power n equal 0 into x power n means 0. Now we should take summation on both sides. As given condition is that n greater than or equal to 1. So summation should start from 1 to infinity. So we should take in summation as sigma n equal to 1 to infinity an into x power n minus 7 into sigma n equal 1 to infinity an minus 1 into x power n plus 10 into an minus 2 10 into sigma plus 10 into sigma n greater than or equal to 2 here. Sigma n equal 2 to infinity an minus 2 into x power n equal 0. So we know that g of x means sigma n equal to 0 to infinity an x power n. Here summation start from 2 to infinity. So from g of x if you remove the first two terms then it will be equivalent to this. So this can be written as g of x minus a naught minus a1x minus 7 into, here difference, see the difference, here n is 2, here it is 1, 2 minus 1, 1. So first term should be subtracted from g of x which should be multiplied by x power 1. So we can write as 7 into x into g of x minus a naught plus 10 into, here 2 both are same. So no need to subtract anything from g of x but multiplied by x square. So 10 into g of x into x square equal to 0. Now from the left side take g of x terms as common. So if you take g of x as common we will get 1 minus 7x plus 10x square equal, remaining terms take right side, minus a naught becomes plus a naught, minus a1x become plus 7a1x, here 7a naught x, if you go right side will become minus 7a naught x. Now substitute initial values here. What are the initial values? A naught equal to 3, a1 equal to 3. Substitute here. So 3 plus 21x minus, this is a naught plus a1x. So this become, so if you go it right side it become a naught plus a1 into x, this plus 7a naught x, that will go minus 7a naught x. Now substitute a naught a1 values here. A naught means 3, so 3 plus a1 means 3x minus 7 into a naught means 3, 7 into 3 21x. So 3 minus 18x. Now take this term to right side. So we will have, that implies g of x equal 3 minus 18x by 1 minus 7x plus 10x square. So now we got g of x equal 3 minus 18x by 1 minus 7x plus 10x square. Now we have to find fractions for this one. So next one, so g of x equal 3 minus 18x by 1 minus 7x plus 10x square. Now for this we have to find fractions. So 1 minus 7x plus 10x square. For 10 factors, 5 into 2. So we can write as 1 minus 5x minus 2x plus 10x square. So we can take as 1 as common here. 1 minus 5x minus 2x common is say 1 minus 5x. So we have 1 minus 2x into 1 minus 5x. That are the factors for 1 minus 7x plus 10x square. So we can write this as a by 1 minus 2x plus b by 1 minus 5x. So 3 minus 18x by 1 minus 7x plus 10x square equal, if you take LCM here, 1 minus 2x into 1 minus 5x, we will get a into 1 minus 5x plus b into 1 minus 2x. So take numerator parts. So a into 1 minus 5x plus b into 1 minus 2x equal 3 minus 18x. Compare constant terms and x coefficients on both sides. So we will get a plus b equal to 3 minus 5a minus 2b equal to minus 18. For example, multiply the first equation with 2. Then we will get 2a plus 2b equal to 6. So keep second equation as it is. Minus 5a minus 2b equal to minus 18. Plus 2b minus 2b gets cancelled. 2 minus 5. So minus 3a equal to minus 12. That implies a equal to 4. If a equal to 4, then b, what is b? b equal to 3 minus a. 3 minus 4 equal to minus 1. So after solving, we got a equal to 4, b equal to minus 1. Substitute here. So g of x equal to 4 by 1 minus 2x minus plus b minus 1, that's minus 1 by 1 minus 5x. That equal 4 into, this is in the form 1 by 1 minus ax. So 1 by 1 minus ax is equivalent for sigma a power n x power n. So it can be written as sigma 2 into 2 power n into x power n plus minus 1 into sigma 5 power n x power n. So take sigma x power n as common, we will get 4 into sigma 2 power n minus 1 into sigma 5 power n. So that is the solution for the given problem. So AN will be 4 into sigma 2 power n minus 1 into 5 power n. So that is the solution for the given problem. Now we will go with next problem. So solve the linear reconciliation Sn plus 3 into Sn minus 1 minus 4 into Sn minus 2 equal to 0 for n greater than or equal to 2 and with initial conditions S naught equal to 3 and S1 equal to 2. For this we have to solve. So as usual, we will assume let g of x equal sigma n equal to 0 to infinity Sn into x power n. Multiply the given equation both sides with sigma x power n. So Sn into x power n plus 3 into Sn minus 1 into x power n minus 4 into Sn minus 2 into x power n equal 0 into anything is 0. Here condition given is n greater than or equal to 2. So summation should start from 2. So we should take as, that implies sigma n equal 2 to infinity Sn into x power n plus 3 into sigma n equal 2 to infinity Sn minus 1 into x power n minus 4 into sigma n equal 2 to infinity Sn minus 2 into x power n equal 0. Here summation starts from 2 to infinity. That's why from g of x we should remove first two terms. So we can write as g of x minus s naught minus s1x plus 3 into x into, here difference is 1. So first term should be subtracted, multiplied by x. So 3 into x into g of x minus s naught minus 4x square into g of x should be written as it is equal 0. That implies take g of x as common, then we will get 1 plus 3x minus 4x square. Take the remaining terms to right side. So minus s naught will become plus s naught, minus s1x become plus s1x, minus 3x x naught will become plus 3x into s naught. So substitute initial values here, s naught equal to 3, s1 equal to 2. So we will get s naught means 3 plus s1 2x plus s naught means 6 into 3 18x, s naught means 3 into 3 9x, so 9x here. So 3 plus 11x, this become g of x equal to 3 plus 11x by 1 plus 3x minus 4x square. Now we have to find factors for this one. G of x equal to 3 plus 11x by 1 3x minus 4x square. So it is 3 plus 11x by 1 plus 3x minus 4x square. So we can write as 3 plus 11x by 1 plus 4x minus x minus 4x square. So that equal 3 plus 11x by, from first two terms take 1 as common, 1 plus 4x minus take 1 as minus x as common, 1 plus 4x. So we are having 3 plus 11x by 1 minus x into 1 plus 4x. So now we can find partial fractions for it. So it can be written as that equal a by 1 minus x plus b by 1 plus 4x. So you take LCM, 1 minus x into 1 plus 4x, then we will get a into 1 plus 4x plus b into 1 minus x. Compare numerator terms on both sides. So we will get 3 plus 11x equal to a into 1 plus 4x plus b into 1 minus x. Compare constant terms and x coefficients on both sides. We will get a plus b equal to 3, 4a minus b equal to 11. So you add on both sides, we will get 5a equal to 14. So a equal to 14 by 5. So if a equal 14 by 5, b equal to 3 minus a. That implies 3 minus 14 by 5. 15 minus 14, 1 by 5. So a becomes 1 by 5. So a becomes 14 by 5, b becomes 1 by 5. Substitute here. Therefore, g of x equal to a means 14 by 5 into 1 by 1 minus x plus what is b here? B is 1 by 5. 1 by 5 into 1 by 1 plus 4x. So 14 by 5 into, we know that it is in the form 1 by 1 minus ax. 1 by 1 minus x is equivalent to sigma a power n x power n. According to that formula, it can be written as sigma 1 power n into x power n plus 1 by 5 into 1 by 1 plus 4x can be written as 1 minus of minus 4x. So it is nothing but 14 by 5 into sigma 1 power n into x power n plus 1 by 5 into, for this, sigma minus 4 power n into x power n. So comparing exponent coefficients on both sides, we will get an equal Sn equal 14 by 5 into 1 power n plus 1 by 5 into minus 4 whole power n. So that is the solution for the given problem. So this is how to solve linear reconciliations using generating functions. Now see one more problem. Solve the linear reconciliation an equal 4 into a n minus 1 minus 4 into a n minus 2 plus 4 power n with n greater than or equal to 2 and a not equal to 2 and a1 equal to 8. So as it is a non-homogeneous, we have to keep 4 power n on right side, take remaining terms to left side. So it will become an minus 4 into a n minus 1 plus 4 into a n minus 2 equal 4 power n with n greater than or equal to 2. Now multiply with x power n on both sides. So we will get an into x power n minus 4 into a n minus 1 into x power n plus 4 into a n minus 2 into x power n equal 4 power n into x power n. Now take summation on both sides. So here condition given is n greater than or equal to 2. So summation we should start from 2 to infinity. So we can write as sigma n equal 2 to infinity an into x power n minus 4 into sigma n equal 2 to infinity a n minus 1 into x power n plus 4 into sigma n equal 2 to infinity a n minus 2 into x power n equal sigma n equal 2 to infinity 4 power n into x power n. Here we know that first initially we will assume that g of x equal sigma n equal to 0 to infinity a n into x power n. So if we remove first two terms from g of x, this we will get. So g of x minus a naught minus a1x minus 4 into, here difference is 1. So first term should be subtracted followed by x power 1. So 4 into x into g of x minus a naught plus, here both terms are equal. Now given term should be written as it is followed by x square equal, here normally sigma n equal to 0 to infinity a power n x power n formula we are having 1 by 1 minus ax. Here summation is starting from 2 to infinity. That means from the given formula we have to subtract first two terms. So we can write as 1 by 1 minus 4x minus 1 minus 4x. Now take from the left hand side, take g of x as common, we will get 1 minus 4x plus 4x square, take remaining terms minus a naught minus a1x plus 4 a naught x equal 1 by 1 minus 4x minus 1 minus 4x. Now apply initial values here, a naught equal to 2, a1 equal to 8, substitute here, then we will get g of x into 1 minus 4x plus 4x square minus a naught means 2 here minus a1 8x plus 4 into 2 8x equal 1 by 1 minus 4x minus 1 minus 4x. Here 8x minus 8x gets cancelled. So take minus 2 to right side. So we will get, that implies g of x into 1 minus 4x plus 4x square equal minus 2, if we go to right side it will become plus. So 1 by 1 minus 4x minus 1 minus 4x plus 2. 2 minus 1 is 1. So we can write as that equal 1 by 1 minus 4x plus 1 minus 4x. Now take LCM here. So that equal 1 by 1 minus 4x plus 1 minus 4x. Now take LCM here. 1 minus 4x. So 1 minus 4x plus, here assume denominator as 1. Here assume denominator as 1. So it will become 1 minus 4x into 1 minus 4x. So it is nothing but 1 minus 4x plus 1 minus 8x plus 16x squared by 1 minus 4x, that equal to 2 minus 12x plus 16x squared by 1 minus 4x. All this is equivalent to g of x into 1 minus 4x plus 4x squared. LCM on both, take LCM here. So we will get 1 minus 4x. Here 1 we will get 1 plus here 1 minus 4x into 1 minus 4x. So 1 minus 4x whole square. So we will get 1 plus 16x square minus 8x by 1 minus 4x. So we will get 2 minus 8x plus 16x square by 1 minus 4x. All this is equivalent to g of x into 1 minus 4x plus 4x square. Now we will get, that implies g of x equal to 2 minus 8x plus 16x square by 1 minus 4x into 1 minus 4x plus 4x square. So it can be written as 2 minus 8x plus 16x square by 1 minus 4x into, here see 1 minus 4x plus 4x square. It is in the form a minus b whole square. So it is nothing but 1 minus 2x whole square. So we can write as a by 1 minus 4x plus b by 1 minus 2x plus c by 1 minus 2x whole square. In that way we can find partial fractions. So if you compare numerators, 2 minus 8x plus 16x square equal to, if you take LCM here, a into 1 minus 2x whole square plus b into 1 minus 2x into 1 minus 4x plus c into 1 minus 4x. So if multiply, expand it, a into 1 plus 4x square minus 4x plus b into 1 minus 6x plus 8x square plus c into 1 minus 4x. So comparing constant terms, x coefficients and x square coefficients, we will get a plus b plus c equal to 2 plus 8b equal to 16. For a plus 8b equals 16. Comparing x coefficients, minus 4a minus 6b minus 4c equal to minus 8. So we are having three equations. One is a plus b plus c equal to 2. Other equation is 4a plus 8b equal to 16. Third equation, minus 4a minus 6b plus 4c equal to minus 4c equal to minus 8. Equal minus 8. So these are the equations. On solving this, we have to find the values of a, b, c. So multiply 4 with first equation with 4. So we will get 4a plus 4b plus 4c equal to 8. See the third equation, minus 4a minus 6b minus 4c equal to minus 8. Here 4c gets cancelled, 8 minus 8 cancelled. So minus 2b equal 0. That implies we got b as 0. So you obtain b as 0. So if b is 0, then 4a equal 16. That implies a equal 16 by 4. So we got a equal 4, b equal 2. Substitute a, b values here. Then c equal 2 minus a minus b. So 2 minus 4 minus 0 minus 2. So after solving we got a equal to 4, b equal to 0, c equal to minus 2. So substituting here, then g of x equal to 4 by 1 minus 4x minus 2 by 1 minus 2x whole square. Let us see. So as b is 0, we got like this: 4 by 1 minus 4x minus 2 by 1 minus 2x whole square. So we will take 4 into 1 by 1 minus, it is in the form 1 by 1 minus ax. It is equivalent to sigma a power n x power n. So we can write as sigma 4 power n into x power n minus 2 into, here it is in the form 1 by 1 minus ax whole square. So for this formula is n plus 1 into a power n. So for this n plus 1 into 2 power n into x power n. So comparing x power n quotients both sides, we will get a n equal 4 into sigma 4 power n minus 2 into n plus 1 into 2 power n. So that is the solution for the given equation. In next class we will solve some more examples. Thank you.